Why haven't we met any aliens yet? Let's set aside Roswell for a second and imagine that we haven't made first contact just yet. Our universe is mind-bogglingly humongous, right? So why haven't the little green humanoids landed on the lawn at Buckingham Palace during the changing of the guard? This is the Fermi paradox. Despite billions of stars and even more potentially habitable planets orbiting those stars, as far as we know, we still haven't seen someone build a mountain of mashed potato inspired by an alien or hum a mathematical musical tune sent from a distant civilization. But could there be a simple explanation for having never met an alien called Paul? Yes, civilization timing mismatch. Two advanced civilizations might emerge, but at drastically different points in time. Given the vast scales of cosmic time, billions of years, one civilization might rise, become technologically advanced, and then flush itself down the toilet of fallen civilizations long before another civilization even begins to evolve. Essentially, civilizations could be too far apart to overlap in time or communicate. This temporal factor reduces the likelihood of two civilizations being technologically advanced at the same moment. Even if intelligent life were common in the universe, the fleeting nature of advanced civilizations, whether due to self-destruction, natural disasters, or our soon-to-be AI overlords, could mean they rarely, if ever, exist simultaneously and never get the chance to interact. This would explain why, despite the potential for many habitable planets, we don't detect other advanced life forms. We continue to be a loner on the cosmic dating site. It's a real downer, right? Or perhaps not. If we find just one tiny morsel of life in our solar system, it would transform our understanding of biology and the universe. It would suggest that life isn't a rare anomaly, but a common thread, woven into the fabric of the cosmos. And if life can arise independently in multiple places in our own solar system, the chances of life elsewhere, in the billions of other solar systems, becomes staggeringly high. So where are we looking within our own solar system? Once a world of raging dust storms and a barren landscape, Mars wasn't always so desolate. Billions of years ago, this red planet had a vastly different face. Evidence suggests that Mars was once home to vast lakes, flowing rivers, and even an ocean covering much of its northern hemisphere. Today, NASA's rovers are exploring the planet's surface, looking for signs of ancient life. The Curiosity and Perseverance rovers have found traces of organic molecules, minerals that form in water, and even the remnants of ancient riverbeds. The Perseverance has been collecting rock samples from an ancient lakebed in the Jezero crater, a location scientists believe could hold fossilized microbial life. But Mars presents a mystery. While it was once warm and wet, something caused its atmosphere to thin and its surface to freeze. Did life ever take hold during its early, more hospitable days? And if so, did it adapt to survive in the harsh conditions that followed? By studying Mars, we not only look back in time, but we also learn more about how life might arise and endure in other places of the cosmos. Next, we travel to Europa, one of Jupiter's moons. Europa shines brightly in the night sky, its icy surface reflecting the sunlight 5 times brighter than our own moon. Beneath this frozen crust lies an ocean so vast that it could contain twice as much water as all of Earth's oceans combined. NASA's Europa Clipper mission, launched from Cape Canaveral, Florida, is now on its way to investigate this alien ocean. The spacecraft will travel 1.8 billion miles, using the gravitational pull of Earth and Mars to gain the momentum needed to reach Europa by 2030. Equipped with cutting-edge instruments, the Clipper will map Europa's surface, analyse dust particles, and search for water plumes erupting from the moon's icy shell. Europa's potential for life stems from decades of discovery. Back in the 1970s, scientists found water ice on its surface. Later missions, including Voyager and the Galileo spacecraft, revealed reddish-brown cracks crisscrossing Europa's icy crust, suggesting salts and compounds that could support life. In 2012, the Hubble Space Telescope detected possible water plumes shooting into space. But Europa isn't an easy target. Its surface is bombarded by intense radiation, equivalent to 1 million X-rays with each flyby. To survive, the Clipper spacecraft's electronics are housed in a heavily shielded vault. Despite the challenges, Europa remains one of the most promising locations for finding life beyond Earth. a hidden ocean that could hold secrets waiting to be uncovered. Beyond Jupiter lies Uranus, an enigmatic planet with 5 large moons and many other small ones. The large ones consists of Miranda, Ariel, Umbriel, Titania and Oberon. For decades, these icy moons were thought to be frozen and lifeless, but recent research has changed this view, suggesting they may harbour hidden oceans beneath their icy surfaces. Our knowledge of Uranus stems largely from Voyager 2's flyby in 1986, which revealed a seemingly inactive system. Yet there are images of the moon Miranda showing hints of geological activity, raising questions about what lies beneath its surface. Scientists now believe that Voyager encounter with Uranus occurred during a powerful solar storm, which likely distorted the planet's magnetic field and may have masked signs of activity. NASA's up-and-coming orbiter and probe mission, set to launch in the 2030s, aims to explore the planet and its moons in greater detail. By 2045, we could finally uncover whether any of these moons orbiting Jupiter, Saturn or Uranus are home to alien oceans. And if we found just one tiny morsel of life, it would change everything.